Welcome back to Tightwad Workshop. If you're a regular viewer, you've probably noticed that I'm taking a lot longer between uploads lately. That's because I've gone and gotten myself hooked on a new computer game, Rust. I mostly play as a pacifist gardener and constructor of ludicrous buildings. But even if you carefully avoid combat with other human players, your avatar will still be seeking regular revivals after encounters with wildlife, falling from high structures, starvation, your own livestock, and even by cactus. But today we're going to show you how the plant breeding module works inside Rust. So all farmable plants in Rust have these 6 DNA positions, and these 5 available options to fill them. A green G represents a higher growth rate, so the more Gs, the faster the plant will mature. A green Y represents yield, so the more Ys, the more pumpkins or potatoes or whatever you'll get out of the plant. A green H represents hardiness, or how well the plant will survive if the soil moisture or temperature isn't in its ideal range. A red Y means that the plant will use more water than normal. This isn't a big problem if you're using an irrigation system like this, but it is a nuisance if you need to carry water to your garden manually. A red X is neither good nor bad, but it does mean that this position can't be filled by a more useful green DNA value, so from an efficiency point of view, it's wasted. Now for most purposes in Rust, an ideal plant will have 3 Gs for growth and 3 Ys for yield. It doesn't matter what sequence these are in, any of these patterns will still count as a GGGYYY. You can establish a new plant in your Rust planter by planting either a seed or a clone. When you plant a seed, you get a randomly generated genome like this. If you plant a clone, you'll get the same genome as the clone every time. This means that if you've spent the time crossbreeding a high-quality plant clone, you'll always get a reliable, predictable crop from it. Now Rust plants also have 6 distinct growth phases. The first phase is seedling. This is the phase that the plant starts in, when you've just placed the seed or the clone into the soil. Sapling is the second phase of growth, where the plant has become noticeably bigger. You can clone the plant in this phase. Crossbreed is the phase where the plant is exchanging DNA with its neighbouring plants in the planter. You can't clone or harvest the plant during this phase. In the mature stage, the plant has finished crossbreeding and you can either harvest it for its basic food value or you can clone it. In the fruiting phase, the amount of food available from a harvest steadily increases from the basic amount to the maximum amount for the plant's genetics. You can either harvest or clone the plant at any time in this phase. The ripe phase is the final stage of plant growth, where you can harvest the plant for its maximum food or clone it. The time that it takes for a plant to go from seedling to ripe will vary depending on its genetics and the environmental conditions, but for most combinations of genetics, it'll usually be ripe in around about 90 minutes. Now whether you're using a single planter on top of a log cabin or a full grow house with lighting and irrigation, you'll still need to start by gathering seeds. For food plants like pumpkins and corn, you can get extra seeds by eating the fruit, like this. But for non-edible plants like hemp, you need to gather all your seeds from plants growing in the wild. In this video I'm going to keep things simple and show the process using a single square planter on top of this cabin. When you first install a planter, it'll be totally dry, so the first thing we need to do is water it. A square planter like this has 9 positions for seeds. When a plant reaches the crossbreed stage, it'll share genetics with the plants in its adjacent positions. A plant in the centre will crossbreed with all 8 surrounding positions, but a plant in one of the corners will only share genetics with its immediate neighbours. Now we can select our first pumpkin seed and plant it here in the corner position. The basic rules that I follow for choosing whether to keep or weed out a plant are 5 or more green, keep. Less than 4 green, weed. 4 green and more than 1 H, weed. This plant has 4 green and only 1 H, so we'll keep it. Now we can move to the next corner and plant another seed. This one only has 3 green DNA cells, so we'll use our pickaxe to weed it out. Now we can switch back to our pumpkin seeds and try again. That's another one for weeding. I'll keep repeating this process until we have a usable plant seedling in each corner of the planter. Sometimes you'll get lucky and only need to use 4 seeds to get your 4 good seedlings, but other times you'll need a lot more. This one has more H's than I'd like, but since it has 5 greens, I'll keep it. As you can see, we can't do anything to these plants using the pop-up menu while they're in the seedling stage. We will need to wait about 10 minutes for the plants to get to the sapling stage so that we can clone them. So now our first plant has reached the sapling stage and we can use the pop-up menu to clone it. I'll press Tab to go into the inventory view, and as you can see, we now have 2 clones of our plant with a WGGYYH genome. We only got 2 clones because this plant doesn't have any yield genes. 2 clones is the default amount that you'll get in this case. While we wait for the other 3 plants to reach sapling stage, we can replant a new one in this empty corner. We'll follow the same keep weed rules as before. If you prefer to stay at your planter and keep a close eye on it, you can fill all 9 positions with plants to make this initial breeding step go faster. You have to be careful not to let any of them reach crossbreed stage though, or your planter's just going to end up full of random genetic soup. You might also need to top up the water in the planter from time to time. As before, we'll clone each plant as it reaches the sapling stage. Once we've accumulated a dozen or so sample plants, we can check if we have enough to breed a GGGYYY clone. I like to do this from inside the cabin, so I won't get attacked by dangerous animals while I'm working. I'll switch to my browser window, where I've already opened a tab to RustBreeder.com. Now you can always manually type in the 6-character genome of each of your plants, but it's a lot easier to use RustBreeder's scan option. Just press the scan button and you should jump automatically back to Rust. Now I'll open my inventory and select my first clone. After a few seconds we should hear a pop noise, which means that RustBreeder has successfully scanned this plant. Now we'll move from left to right along each line, scanning each plant as we go. Once we've scanned all of the plants, we can switch back to RustBreeder and see our samples. Our next step is to press the Calculate button. Now RustBreeder will analyse all of the possible combinations of our samples and let us know what we can breed from them. We need to wait until the progress bar is finished moving along here. So according to this report, the best we can get is an all-green clone that still has 1 H in it. But we want to see if we can make a GGGYYY clone. So I'll use these filter controls at the top of the page to select that. And RustBreeder now tells us that we don't have enough variety in our samples to breed one of those. So we're going to have to go back and find some more seeds. One way to do that is to pick our sample with the most yield and growth genes and use it in our planter. We've planted 3 clones, so we can clone one of these to get our YGXYGX clone back again, and harvest the other 2 for pumpkins once they ripen to get more seeds. That's going to take about 90 minutes though, so while we wait, I'll go and see if I can find some more wild pumpkin plants. So here we're cloning our middle plant, and once the other 2 plants are ripe, we can harvest them for 8 more pumpkins. Now we can eat our pumpkins to get more seeds. Unlike in real life, you can keep eating pumpkins all day here without getting sick. After a few more cycles of seedling cultivation, we now have 30 clones, so let's try the calculator again. I've replaced the cabin's small box with a large one to make the next step a bit easier to follow. We'll start by putting all of our samples into the large box. Now we'll switch back to RustBreeder and start a new calculator tab. We'll use the scan button the same as last time and scan our samples. Now we can switch back to RustBreeder and press the Calculate button. Because we have a lot more samples this time, the calculation process will take a bit longer. RustBreeder is now recommending a clone with 5 Gs and only 1 Y, so let's reset the filters to GGGYYY like we did before. Okay, so the good news is that we can now breed a GGGYYY clone from our current set of samples. This gen.2 marker is telling us that it'll be a 2-step process. We'll need to perform a first crossbreed to get this HYYYYG plant, then we'll use it to breed our final GGYYYG plant. Let's click on this set of cards to get our recipe. And now we'll click on the gen.1 card to get its recipe. So we have a 100% chance of breeding our desired clone in one pass, which is good. Our first surrounding plant is a number 5, so I'll jump back to Rust and put one of those onto my tool belt. Our next surround plant is a number 6, so once again I'll switch back to Rust and put one of those on my belt as well. Our final surround plants are a number 8 and a number 10, so we'll add those to the tool belt. And this writing means that we can use any pumpkin plant seed or clone for our centre plant, which is the one that we'll be deliberately crossbreeding. So I'll switch back to Rust and select our clone that has the most growth genes, because that'll mean less waiting time for us. Now we can go back up to our planter and plant our centre plant. We want this plant to get to the crossbreed stage before any of its neighbours, and the simplest way to achieve that is to wait until it's almost finished its sapling stage before we plant the others. So now we just have to wait a few more minutes for the crossbreed stage. It plays this fancy pollen shower animation when that happens, so it's hard to miss. So as you can see, we've now got our HYYYYG plant. But we won't be able to clone it until we finish the crossbreed stage and move into mature. Once the plant's reached maturity, we can now clone it. And a few minutes later the surrounding plants will all get to sapling, and we can clone those as well. Now we can go back to our DNA samples box to drop off our clones. And now we can set up the second crossbreed. This is done in the same way as the first one, but this time we need to use a number 30 as our centre plant, and we'll be using our new gen.1 clone that we just bred as our first surrounding plant. So once again we wait until the centre plant is about a 90% sapling, then we plant the surrounding plants. A few minutes later the centre plant will go into crossbreed, and a few minutes after that it'll be mature and we can clone it. We've done a lot of work to get this clone, so it's a good idea to take it inside right away, and maybe send one copy of the clone away for safekeeping with a friend or a teammate. Now that you have a GGGYYY clone, it's usually just a one-step crossbreed to get a 4Y or a 5Y clone, if you like the higher yielding varieties as well. So now that we've finished our hard day's work, what better way to celebrate than with a party? Tightwad Workshop is filmed in front of a live studio audience.